All right, good afternoon and welcome to today's webinar. Thank you for joining from wherever you are joining. I'm going to be your host today. My name is Michael Petch. I'm the Editor-in-Chief of 3D Printing Industry. And thanks for joining this webinar on what to look for in your first professional 3D scanner. Thanks to everyone who's joined so far. More people are filtering in. This is a live event, so why not take a moment and let me know where you're calling in from. You've got the chat function there, and Paolo's first to find it. Yes, good afternoon from Switzerland. Thanks for joining us today. All right, so a little bit of housekeeping here. I can see people are starting to find the chat function. Fantastic. There's also a separate Q&A function, and you can find that by locating and clicking the speech bubble icon. It's just located below the chat icon on that vertical bar next to the chat window on the right hand side of the screen. That Q&A function, we're going to be using that to pose any questions you've got for today's speaker. So please make sure you put your questions in the Q&A rather than in the chat, and that will make sure we don't miss anybody and we're able to get those answered. So today's webinar will be recorded and it will be available for replay after the event, although I do encourage you to stay for the actual live event because that's your chance to ask questions about anything you hear. And before I ask our expert speaker to join, let me make a quick introduction. So the webinar is focused on the scan-to-CAD process for mechanical part design projects. The topics we're going to be talking about today include the cleaning tools, how to seamlessly merge multiple scans, Peel.CAD's options for creating various geometric entities, transferring ready-to-use data to your CAD software, and of course, we're going to give you some real-world project examples demonstrating these tools in action. Right, so joining us to go through these topics is Gabrielle Williams, who is an applications engineer at Creaform. Gabrielle is a US Navy veteran, graduated in mechanical engineering, and as I said, is an applications engineer and project estimator for Creaform since 2017. Gabrielle has trained customers, distributors, and fellow employees on the Creaform and Peel 3D metrology systems across the USA, Mexico, and further afield. So with that, I would like to welcome Gabrielle to the stage.
Hello.
Welcome, Gabrielle. Hello, good to see you.
Good to see you too. How are you doing today?
Very well, thank you. So I've given the introduction. People are primed. They're ready to hear what you've got to say. I'll leave the stage to you and see you later for the Q&A.
Wonderful. All right, so I'll just go ahead and share my screen over here and let me know if everybody can see it. Maybe give me a thumbs up or good to go on the chat here. All right, looks like everybody can see it. Perfect. Okay, so I'll go ahead and get started. As mentioned, my name is Gabrielle. I've been with Creaform for 7.5 years, almost 8 years. And as you might know, Creaform has been around for 20 plus years or so. So I'm new to the game in ballpark speaking. So let me go ahead and pull up my information here. Okay. So for today's webinar, I'll be taking you through a deep dive into what we believe are the most important aspects of what you should be considering when you're searching for the right 3D scanner. So here's what our agenda will look like for this webinar. First, just a brief introduction on Peel 3D and its sister brand Creaform. Then second, we're going to have a presentation of the most important aspects to look for when aiming for the best 3D scanning workflow. Then a live demo focused on those aspects. And lastly, some time for some Q&A. But please feel free to ask questions at any time by typing it into the questions section of the meeting. You don't need to wait until the end. So if a question pops up into your brain, go ahead and type it and we can answer them at the end. So please take a moment to find that section now in the meeting box. In the meantime, I'll explain a little bit about Peel and its sister company, Creaform. Peel is the entry-level brand of Creaform, the world-renowned leader in metrology-grade 3D scanners. We are the pioneers in the industry. Our handheld 3D scanners and their tools are used all over the world by major OEMs in the automotive industry, aerospace industry, national museums, and much, much more. They're used both for inspection and design purposes, and 3D printing, of course, as well. We also offer automated 3D measurement solutions, so you can always stick a 3D scanner right onto a robot to make it do all the work for you. And we also support our customers worldwide with metrology services and engineering services, which means that our engineers are using our own tools internally every day. So we know firsthand what issues our customers might be running into and how to improve those workflows. Peel was created 7 years ago so that professional grade scanners could be more accessible to people that could benefit from them. And the idea was to bring down the prices on these accurate scanners from Creaform. So although it is a different brand with different distribution channels in some cases, Peel still comes from the same reliability heritage as Creaform, and products are built on the same assembly line. We have the same management team and knowledge behind the solutions. We benefit directly from Creaform's algorithm magic that's been around for 20 plus years and renowned focus on quality. A Peel scanner is simply a safe bet in this market that lately has been full of copycats, unfortunately. It is a trusted and used by major companies in all industries, and we actually over-deliver on our stated technical specifications where others might not live up to the promises on the spec sheets. So what people generally want when they're purchasing a 3D scanner is to gain accuracy in their measurements and save time. So first off, let's consider accuracy. This is something you can find in a product's technical specification sheet. However, there are bad players out there that will flat out lie on their technical specification sheet, and we've tested these scanners. So this is how we know. The best thing I can say is that our company has big name customers that have been with us for years. They've tested our products thoroughly. And so you know that if big guys like different airline companies and automotive companies trust us, for example, our spec sheets are telling the truth. Otherwise, our customers wouldn't be coming back. The second thing we must consider when purchasing a 3D scanner is time savings. So we're really trying to educate our customers out there to look at not only the scan results, but also what happens after the scan, the processing time, the post-treatment capabilities, and more. For a first-time 3D scanner buyer, if there's one thing that you need to remember from this presentation, it's that scanning can take a certain amount of time, but the time that you spend editing that scan, merging it, cleaning it, and extracting the necessary features could be a nightmare if you have confusing software, or maybe the scanner that you're purchasing for your first time doesn't even come with those options, making your scan almost unusable. Our cleanup software is an amazing tool that can help you with all those steps I've just mentioned. And this is the software our engineers use when we're completing projects for our customers. So we personally use these tools every day. I'll show you those tools in a few slides. But for now, let's put aside the cleanup tools and let's consider that even after you've scanned a part, the software still has to finalize and clean the scan. When you look at these tests that we ran on our competitors' products that are approximately in the same price range as us, you can see how much time the setup takes, you can see how much time the scan takes, and then even after you're done scanning, the software now has to finalize the scan. This is like its own way of ensuring that you have a clean scan that looks good. In this little yellow box we've highlighted here, you'll see that this step could take 2 minutes, 4 minutes, 6, or even 7.5 minutes for the same part. So the same part could take 3 times longer to complete, which maybe doesn't seem like a lot now when we're talking about 4 minutes versus 13 minutes. But if you're scanning a car body or some heavy equipment, and maybe you're doing this project multiple times, that's when you really start feeling it. And this doesn't even account for some of the more advanced post-treatment operations we'll discuss in the next slide. So what does that mean? Other than requesting to see the scan from the beginning to the saving step, when you are shopping around for options, what questions should you ask? What aspects of the workflow should you make sure you see? I'm about to show you the important items that you should be asking for when you're shopping around for a 3D scanner. This is what you should ask to see in a demo. First, advanced alignment tools to set a proper reference on your scan. If you're 3D printing, this will allow you to start the 3D print with a good base, so you don't have to worry about rotating the part in your 3D printing software. And if you're creating a CAD based off of your scan, good alignment tools will help you start creating your CAD from a place that makes sense with a good XYZ axis. Then, easy to navigate selection tools are also a great thing. This is how you select certain surfaces on your scan. Can you highlight flat regions, for example? Can you highlight smooth regions without the sharp transitions? Then another great tool to have is measurement tools, so that you can see simple distances and angles between surfaces. Or sometimes if you're creating diameters or circles or cylinders, you want to know what those diameters are going to be. Then you have your advanced cleanup tools. You cannot live without an interactive hole fill tool that lets you control how to fill in any missing areas. Smoothing tools are wonderful for removing noise and spikes while keeping the details of your object. And then the decimate tool is a must, since it will reduce the size of your file while minimizing impact on scan quality. Advanced edit tools include things like the ability to scale your scanned part to be a bigger or smaller part. If you have trimming tools to separate areas of a scan and make them flat, if needed, you can do this if you're doing things like upholstery or decals. And then some people working in the automotive industry, for example, they need the mirror tool because they'll scan the left side of a vehicle and then be able to mirror it and merge the two sides together. That, of course, brings me to the merging function, which is a must. You need a software that can first allow for a good alignment, and then you can confidently merge the two or more parts together. One of the more important things you'll need also, especially if you need to make a perfect part from your scan, is the ability to easily recreate your scan's geometric entities and surfaces. So in the little image there, you can kind of see how some of those geometric entities have already been made and transferred over, in this case, to SolidWorks or Fusion. Which brings me to the last one. You do need to be able to export those geometric entities and surfaces, ideally into using a direct transfer method that allows you to still be able to edit your different features in the project tree of your favorite CAD software. So those are a lot of words, so I'll show you each of those items that I've just discussed so you can see a little bit better of what I mean. Okay, so here I have a part that I've already previously scanned. I kind of just did a quick scan of it, and I didn't clean it up just yet so that you can see the different tools that I'll be mentioning, that I just mentioned here in the presentation here. Okay, so let me pull up my notes here so I can read it as I go along and not miss anything. All right, so as far as alignment options, you do have different options to do this. So let's say that you wanted to bring in, actually, let's do a different one. Let's do this guy right here. So let's say I've already made some features on this part, and then I wanted to align my origin in a place that makes more sense. So right now my origin is floating out here, but if I needed to, I could like maybe put it somewhere, maybe in the center of this circle down here. So what I would like to do is I go to my alignment step, and then out of the features that I've already previously made, so like for example, I already selected my plane. I can go over here and use one of my first planes, and then I can lock it in with my plane XY. So it's locked there. Okay. And if I choose my mind and I decide to do a different plane, I can do that as well too. So choose a different one. Then I can choose to do something like maybe a circle. So I would probably create a circle down here and then align it. I can also rotate it as needed. And if I want to, I can even lock it with a different cylinder or so. So maybe I can lock it with my cylinder there and make my Z-axis go straight through one of these cylinders. So You have different ways of aligning. That's one example. But let's say that you had the two separate parts. And I think in this case, I've already aligned one. So I'm going to delete it or activate it and delete the previous one. Oops. Okay. And so now I have two different parts. And just so we can see them both here, we have them there. And so if I wanted to align them, I need to make sure I have good alignment tools. So another common alignment tool you will do is if you're trying to align two or more parts together. So in this case, I'm just going to align my first one and my second one here. And so these two, sometimes you can align them if you have enough surface that's matching. But in other cases, you might have to manually align them yourself. So in this case, I want to align the bottom one with the top part of this pipe. So I'll just click on one point here, second point here, and maybe a third point there, and do a similar thing for this side. Now you can tell I didn't do it exactly perfect, and that's okay because the software is going to do the rest of the work and match it up nicely for me. So once I see that it's nicely aligned, I can just click on OK, and now I have my two parts aligned together. That's not necessarily merged just yet, but those are some alignment tools that you have at your disposal, along with some other options as well. Next is selection tools. So for a selection tool, maybe let's go back to a different part here. So for a selection tool, I have lots of different options. So you have your typical rectangular selection. So something like this. That's just going to highlight in a rectangular form. But something that's a little bit more fun to do is set and change. So set and change will allow you to highlight not only the part that's turning along with itself here, but also it's smoothly changing. And then once it has a set and change in the mesh, it stops highlighting it. So notice that it only highlights the smooth section of this here. Now, if I needed to grow the selection, I could do that as well. I can grow the selection there, so it's almost like it's flooding. And then, of course, if I needed to shrink the selection, that's also an option too. Another one that's good to use can be similar curvature. So if I'm trying to highlight something that's just a cone shape and not really the sudden, the smooth transition, I can use similar curvature. This is great for highlighting, for creating entities like cones or cylinders. And what's great about our software too, is that if I'm creating a cone, for example, and or let's say I'm creating a plane, it will automatically change to the similar normal function, which means that it's going to highlight the flat zones. So let's say if I wanted to make a plane, I can highlight here, and it's automatically going to select the flat zone for me because it knows that I'm going to create a plane. So it's pretty smart like that, and I really like this. Other tools, you have measuring tools. So let's say that you are creating a cone, a perfect cone relative to your mesh. It will tell you some different measurements about that cone while you're creating them. So for example, half angle, this is telling us that this is approximately 3 degrees of a half angle of a cone. And you even have information like apex, axis, and even the standard deviation and min-max deviation between the mesh and the cone that you're going to create, because it is a perfect cone that you're creating on top of your mesh there. Other measuring tools that are wonderful are things like distances. So if you need to just do a little quick distance to measure from one side to another, you can do that, and then you can see approximately what that length is there. And then you also have things like cleanup tools. So cleanup tools that I mentioned were things like hole fill. So the hole fill is a great one because you can fill in, say I didn't finish scanning all the way in this little area. I can just click on that hole right there and it'll fill it in for me. And I also have the option to do partial hole fills. So if I needed to just get something partially filled like so, I can just select that region and it fills that part for me. And then of course, if I needed to do something like a bridge type of hole fill, then I can just select one side here. And in this case, if I'm going to bring it all the way to this other side like a bridge, I might choose something like a flat curvature. So instead of it bringing it smoothly over, it's going to go straight over to the other side. So these are some different things. You have hole, bridge, and partial. I'll go ahead and hit cancel. Actually, I'll hit undo on the last one and then hit OK. That way I still have the others filled in nicely. Other tools are things like smoothing. So if I needed to smooth out my surfaces, I could do that. You have things like sandpaper. So sandpaper is a nice one because you can really just like blend things slowly. So if I was trying to get rid of a detail, maybe I could just do like this and it kind of smooths it out, almost like a Photoshop type of thing. And you can, of course, change the smoothing strength if you needed to preserve some features and preserve some boundaries. You can do that. Everything, of course, is also has the ability to do an undo. So in case you mess up, it's no problem. You can always go back to. And then decimate. So if we're looking at how many triangles are on this surface, so if we're really looking at the surface, it's made out of approximately 290,000 triangles is how many triangles are on this surface of this mesh. So if I realize that maybe I'm going to send this over to a different software and the software can't hold that much information, I can always click on decimate. And then decimate is going to allow me to change the number of triangles that I have here. I can change the amount of how much percentage of reduction I need. But if I needed to make sure that I don't deviate by a certain amount, I can also lock it with a certain value. If I'm only okay with my mesh changing by, let's say, 0.1 millimeters in any direction, then I would do that. But if I needed to, I can always say, you know what, I want to do 40,000 triangles. And then I'll hit apply, and then I would see what that looks like. So you can see all the number of triangles here is going to decrease on the flatter zones, but you'll still have some smaller triangles on the details to make sure you still have some of that information. So that's really helpful way to reduce your files sizes. And then some of the edit tools that you might be looking for when you're looking for a 3D scanner. So you might want something like mirror. So just a quick little example of how that works. Bring this down. A little example of how that works is I can just draw a line straight down and say, let's see the mirror image of it. And now I have a mirror image of my part. This is wonderful when you're doing symmetric things. So you can easily just maybe scan one side and then mirror it, and you don't have to worry about scanning the other side if you don't want to. Other things that are very useful are things like scale. So if you're 3D scanning a person, for example, and you need to make a little statue of them, then you can say, okay, I want my part to be, my scan to be a different size. So you can say, let's do 0.5 millimeters, and then you have your part that's right there, kind of hidden in there, but it's the smaller version. Now, if instead of saying, okay, I want it to be half of the size, maybe you can say, actually, I just know that my X or my Y needs to be a certain size. So you can say, okay, let's make the X direction 400 millimeters exactly, and everything else can change uniformly as needed. Of course, if you don't want it to be uniform, you can also check that box as well. And then some other things that can be useful are the cut tools, and you can use it by cutting the mesh with the plane, or you can use it by cutting the mesh using curvature selection. So if you needed to just select the mesh and cut different curves out, you could do that. So this would be cutting my part right there. And then lastly is the merge. So I did mention that I had these other two scans, and we've already seen what that would look like if we were to align them. And so this was it aligned, right? But currently they are not merged. I did cheat earlier and I did make a merged item, but I'll also do it in front of you as well, just so you can see what that looks like. So here we'll click on merge. And then I can say I want that one and that one to be merged together. And I will just go ahead and say, yep, I'm ready to apply that. It takes its little time to merge the two together because it's really blending the triangles together to make sure it's nice and all in one. And then I can select that, and then we can see what that actually looks like. So the new item is, I believe, this one here. And that's what, it's not that one, then it's this one actually. So let's see here. So the new item should be right there. There we go. So yeah, that's the one, because that's the one we just aligned as well too. Okay, so that's it for those items. Then we also have things like creating geometric entities and features. So you've seen me kind of create a few things here. Okay, so this isn't the one we're doing. This is the one, because that one doesn't have enough features. So I'll show you what that looks like. So I've created some planes earlier. You've already seen me create some planes. I can also create some cylinders. So when you're creating the features, you really have to think about what you need in order to build the part that you've scanned. So in this case, I would probably make a few planes here and there, and then up here as well on my other flange. And then after I've created my different planes, I'll probably want to do things like cylinders. So I'll go to my cylinder here, and then I can select the surface that I want, where I want to create a cylinder. Now, if I'm creating a cylinder, I do want to consider that I'm going to be using this to build later, and I have to consider what I'm going to be doing. So probably, since this is a hole, I kind of want to make these cylinders longer so that I can easily cut them out in my CAD software, whether that's SolidWorks, Fusion, so on. I'm just kind of thinking ahead whenever I'm doing something like this. And another thing too is I probably also want to create my features using a specific orientation. So if I'm thinking about how this cylinder needs to be in line with the other planes and so on, I probably need to tell my software which how to make it parallel or perpendicular to certain things. So just right now, what I did was I locked it so that this cylinder could be parallel or perpendicular to my plane down here at the bottom. And then I can just hit enter and do it for the rest of the cylinders as well. So this is a nice, easy way to help me build a CAD, which later on I can manufacture in a different kind of way as needed, whether it's 3D printing or whether it's creating it in a CNC. And then I want to make sure that I have the right plane selected too, so I'll change that plane over to plane 10. But yeah, you just go on and you create all the different entities you need. And then once you've created all the different entities, then hold on a second. Then once you've created all the different entities, I'll just go ahead and delete those. Then you can build it in your CAD software as needed. So I'll just go ahead and delete this guy right here. Delete. Perfect. But I think you get the idea on the as far as the cylinders go and the planes go, and you can do different things like your cross sections as well. So in this case, I might choose one of my planes down here, and then I'll say I want there to be a cross section that cuts right through this flange, and I can bring that cross section up right about there. And then once I'm ready, then I can send all these different items to my CAD software. So what I'll do here, now that I've created a few different things, is I'll highlight these items. So that brings me to the last one that I mentioned, exporting your methods to CAD software. So I'll just highlight those items here and then click on send to, in my case, SolidWorks. But if you have Fusion 360, Solid Edge, or Inventor, those are also great softwares where you can import them live and then still edit the different, the CAD as you need. And you can edit the different planes as you need as well. Now, of course, don't worry if you don't have any of those tools, any of those CAD softwares. You can always just highlight the items that you need, and you can export those selected entities as IGES files, step files, and if you needed to save them as CSV or DXF, you could do that as well. So in my case, where I just did a few different cylinders and things, my SolidWorks project opened up on the other side, but you can see my cross section is down here, and I can actually convert that into a sketch, and I can even create an extrusion for that, so I can give it like a thickness as I need to do. And then, of course, after that, I would choose these cylinders and delete them from there. There's other surfaces you can make as well. So I didn't really show you that one too much, but I'll show it to you on the other one, because the surfaces is a really great tool as well. So If let's say that you have a more complicated surface, something like this, for example, where it's not super easy to tell whether it's a plane and then maybe a cylinder, and maybe another plane and maybe a cone. So to make things easier on you, you can easily just select the automatic surface and then just select a little region right there. And then I'm gonna just diminish how much I'm selecting. And then I can say, okay, I want to only make a surface out of this little patch right here. And then I can hit preview. This is going to create approximately 500 patches on my conforming surface. And then from there, I have something that I can easily transfer over to my CAD software, and then I can build things that go up to that surface, or if I needed to cut something with that surface, I can do so there as well. So that's pretty much it as far as the different tools that you want to be looking for when you're looking for a 3D scanner. I think that's pretty much it, but I could do like a little demonstration as well. So let's go ahead and do that just so you guys can see what kind of the scan process looks like, if that's okay. And please remember, if you do have questions, do fill them in your little question and answer box. But I'll go ahead and go to new scan. I'm not going to save the session that we were just working on here. Oh, and I forgot to connect my scanner, so just a second. Plug it in here. A little protective kit is in the way. Let's just leave that over there. Okay, so now that it's connected, I'm thinking everybody can see me okay, right? Everybody can see me still in the little window, hopefully. But I have the different options of how I'm going to scan. Now, in this case, I'm just going to scan a small part. It's going to be not too much detail, and I'm going to let the software do the balanced cleanup. So that was the cleanup we were mentioning earlier. And then I'm going to not scan in color, even though that is an option. If I needed to scan in color, I could. Okay, so I'll go ahead and go on to the next step. And the scanner is ready for me to just go ahead and start scanning. So I'll go ahead and do that. Okay, so actually before we get too ahead of ourselves too, just wanted to say that this is the scanner that I'm using. It's the Peel 3. It came out 2022 in October, so it's on its 2-year anniversary now. And we have a little touch screen in the back. So all I'm going to do is just press the little play button to start scanning. So do that. And you can see live on the screen, it's coming in. And I'm sorry if you can't hear me. I'll try to speak a little bit louder. But as you can see, I'm just going ahead and moving the light towards the surfaces that I'm trying to acquire on the screen. Now, I know it looks a little, rough right here, but that's just what it looks like as the preview. Once I'm done scanning, you'll see it looks a lot cleaner, and I'll easily be able to remove all the excess information around the part that I'm looking for. If I get more close than that, then it won't be scanning at all. So it's kind of just letting me know, like, hey, you're no longer scanning. Maybe try backing up a little bit. And then the same thing goes for if you're a little too far. So that's what that would mean if you see the blue or the red. Now, once you feel like you have the entire scan, then you can just go ahead and is that I can stop, and then I can actually check it myself here. And if it looks good, then I can say, okay, yeah, I'm ready to go. Or if I feel like I need to acquire a little bit more information or something, then I can continue scanning. So it's not like once you stop, you have to be done. You can continue going from there. So I'll just get a little bit more information. If I'm trying to get the internals of those holes that are there, then it's important for me to try to scan and shine the light into those holes as much as possible. So whatever it is that you're focused on, whether it's maybe some attachment points, or maybe you're just trying to find diameter or something, you don't always have to scan everything. You just need to scan what's important to you. In the 3D printing world, you most likely are going to want to scan as much as possible of your part, and then that way you don't have to do as much cleanup or editing later. Okay, so let's be done there, and we can just go on to the next step. As you can see, the software kind of just guides you with everything you need to do. And then also, even it gives you the options to do some cleanup tools really quickly. So what this red stuff is it's just going to be the part that I'm going to delete. And the same thing goes for this. Right now, all I did was I highlighted the part here. And then I just kind of did like a quick invert. And then I can easily just delete what I want to get rid of. So I'll delete this yellow stuff here, and then I go to the next step. Now, if I wanted to merge, I would also be able to merge in this step here too. So you can merge in the Peel.CAD software that I showed you earlier, where you're working with just the mesh, or you can merge with the scans as well. So there's different ways of doing it, and it's really up to you how you want to do it. So once this is going on to the next step, it's going to bring me over to the Peel.CAD software, which is the software that you guys have already seen. And you can see a lot of the cleanup has already been done. So there was some extra noise over here, but it went away. But from here, I can decide to do like a really easy, quick clean mesh where it just cleans up everything all at once. And then from there, I can also decide to maybe fill in some holes that I might want to fill in too. But that's pretty much it as far as the process would go. Yeah, once you're in this step, then you do everything that I showed you from the last few steps, where you do the alignment, the cleanup, filling up holes, smoothing out any of the mesh, and so on. So I think that's pretty much it as far as I have to present. And I think we can open it up to any of the questions now.
Hey, thanks for that. It's great to see a live tech demo going very smoothly, and I think you really sort of showed that just how straightforward it is to use these tools as well. So yeah, that was marvelous. I did see a comment regarding the decimation tools as well. So that was particularly about the lightweighting of the mesh and preserving detail. I think you covered that in a lot of detail, but if the audience has any more questions about that or any other aspects of the presentation, do let us know. So I will start taking a few of the questions we've got coming through on the Q&A channel here. So first off, is there an option to make your mesh watertight for 3D printing? Everyone knows that 3D printers can't print in space. You need to have this manifold mesh. So is there a tool that works with?
Yes, absolutely, there is. So here, there's a few things you can kind of check just to see first. Well, obviously we know this one isn't watertight because we can see the inside of it here. But if you thought maybe it was, you can always go over here and check if it's watertight, and it will say yes or no here. Second, once you've checked on that, there is a tool right here, watertight remesh. Now, typically I try to fill in as many holes as possible just so that I have the full control of like what everything looks like. And then I might click on watertight remesh at the end. The hole fill option is a really great one as well. And even in the beginning, when you're scanning, one of the cleanup options is watertight. So I think under parameters, maybe. Yep, right here, watertight. So yep, thank you, Sebastian. Great question.
We had a question as well here about how much post-scan work you had to do to get to the level of detail that you're showing on assembling in the software. What can you say about it?
Yeah, so you kind of saw me do the scan, so you kind of saw how quickly that was. That's pretty much the speed that I did for the one beforehand. Now the pipes, I didn't scan that one myself. That one was just a file that I imported from like another like Creaform file that I had available. But the scan, the original scan that you saw, like the demo part, it was the same amount of time, and everything you saw was pretty much the work that it would have been to do everything.
Okay. I have a question here about a promo as well. Is there a promotion on here, and how long will this Peel free CAD bundle promo last for?
Yes, great question. So we do have our promotion going on right now with the Peel3.CAD. Now, I'm not exactly sure how long it's going to last, but if you go to our website, as long as it's there, you can see it here. This is the introductory price. Normally it's 12,285 USD, but currently it's 9,990 USD. And I really wish I knew how long it's going to last, but I really have no idea. And this is for the 3D scanner and all those software tools that I showed you. So all of the like Peel.CAD tools that come up here is what it would come with.
Now you've shown us sort of just how capable these tools are, but is there an option to upgrade to, say, to Creaform down the road?
Oh yes, great question. So the Peel 3, as we mentioned earlier in the presentation, Peel is a sister company of Creaform. So Creaform is usually the ones that has like the higher end scanners with very, very, very high accuracy. But we have different levels, so different stages of pricing and different accuracy levels as well. So the nice thing about the Peel scanner is that if you decide to purchase the VI Peel maintenance plan, which is basically I think $400 per year type of situation, then at any point, maybe 2 years down the line, 3 years down the line, if you realize, okay, I've gotten my return on investment on this Peel 3, I'm ready to upgrade to the next best thing in Creaform, you can take the entire cost of your Peel scanner and put it towards a Creaform scanner. So it's almost like you had that scanner for free for those years, and then now you have the new technology from Creaform.
Ah, okay. So, well, I mean, hardware is obviously a big part of the capabilities here, but the software is very vital as well. How often do you update the software?
Yes, that happens maybe 2 or 3 times a year. So you can always go onto the portal, check to see what the newest version is, download the installer, and then install it on your computer.
And are those licenses tied to the scanner, or are they per user?
The software, well, you can put the software on as many computers as you want. Of course, you wouldn't be able to scan unless you have the physical scanner itself. So that would be available everywhere. But as far as Peel.CAD goes, that one, if you need it on multiple computers at the same time, then that would have to be multiple licenses that you would purchase.
Okay, but if I'm using maybe my laptop one day and my desktop another day, then
Not necessarily. So if you're actually bouncing from your computer and you're the only one using it, let's say, and then you're using it somewhere else later on, you can just switch it over to the other.
oh, great.
There's no issue there, but it's more like if you have 2 people using it at the same time, then you
Gotcha. And do you need to have an internet connection to run this?
You do not need to have the internet connection while you're scanning, while you're doing all the Peel.CAD. You would have to, however, at least check it out, I guess you could say. So maybe an internet connection just to say, hey, I'm going to be working, without internet, and that's okay. But basically, I'm the licensed owner is all you're really doing.
Yes. Okay. So if I'm doing my hobby, say in the garage, which isn't particularly stable connection, I can still be scanning parts out there. Yeah.
Right. Yeah. No problem at all there.
On that, how would you go about scanning an entire car?
Yeah, no problem. So we have an Instagram page where we have people doing that kind of thing all the time. So feel free to check out our Instagram page. But yeah, you would be able to just scan an entire car by putting stickers on maybe some of the flatter regions so that the scanner can continue tracking, or maybe something that's more repetitive. But you just you can just start scanning and just connect it all together. In this case, it was a small part, so you don't really get to see it, but you would do the same idea. You would just shine the light everywhere, and then it would come in on the screen.
And is there a maximum size object that you can scan?
We have recommended part sizes, but it's really up to you as long as you're okay with the accuracy and you have a powerful enough computer for all that data as well. But the accuracy is 0.25 millimeters per meter. So you can scan a boat, let's say, as long as you're okay with having 0.25 millimeters off for every meter of that scan that you're doing. Every meter length, I guess you could say.
You talked about the interoperability with a couple of well-known software packages. Can you also export to Onshape?
Yes, so Onshape can take step files and IGES files, I presume, right?
I believe so, yes.
Okay, so yes, as long as you can export any features with, or import any features with IGES files or step files. So, as I was doing one here, you can just right click, export selected entities, and then you would save it however you need to save it, which I believe Onshape probably takes IGES files and step files. And then from there, you would import those items into Onshape and build from there.
So I wonder, you've been doing this for a while now. What are some unexpected ways customers have incorporated 3D scanning into their business?
Oh, this is really fun. Okay, so some projects, okay, well, there's so many different things you could do. You can do reverse engineering where you're just creating a CAD based off of your scan. But then a lot of big companies will also scan a part and then they'll compare it to a CAD. So you bring a CAD, you overlay it with your scan, and then you can kind of see like a color map comparison of the part. So kind of, I'll maybe kind of show a little bit of example of what that might kind of look like. I'm just going to do like a super quick clean of something here and then just hit OK. So a compare tool that you might see is where you're comparing. In this case, I'm going to compare the mesh with its previous step. So here's a color map comparison where just right now I did a second of doing like spike removal on the part. And then if I show the different deviations, like the largest deviations, it shows that right here, I cleaned up by more than 1 millimeter in each direction. So that's kind of what it would look like, where you would have a CAD compared to a scan, and you can tell, in a report how off your part is compared to that CAD. It might say, okay, this diameter is 1.125 when it should really be 1 millimeter. And then you can say, if that's acceptable or not, or if it passes or if it fails. That's the typical stuff. But more fun projects are things like you can 3D scan a person and put them in a movie or a statue or something like, I think it was like maybe Van Helsing or something that we actually scanned like a gargoyle from Italy or something. And then we put it in his basement and it was there like kind of as just like a prop that wasn't actually physically there. In my case, I actually got married and I 3D scanned myself. I had a friend 3D scan me and I scanned my husband. And then I scaled us down and I was wearing my wedding dress, of course, for the wedding, for the scan. And I scaled us down and I put us on a little platform and then I 3D printed both me and him and put us on the cake topper. So it actually looked like.
Oh, that's lovely. That's very nice.
Yeah, that was a really fun one. But yeah, there's so many different projects. I think one of my more favorite ones also is, it was like a museum that wanted to show off some really cool geodes and rocks and things. And what they would do is they would scan, like during the demo, we kind of figured out the workflow for them, which was like a fun part for me because I was like, oh, I was getting inventive and creative. Like, okay, this is what you would probably do. And so we would 3D scan their rocks, and then I would be able to create a base for that rock, and that's what they would use to hold the rock like as a stand in their museum or in their website or something. And then they would 3D print a perfect stand that conforms perfectly to any of the geodes that they had.
Sort of related to rocks and possibly, but jewelry. We have a question about is the scanner suitable for working with jewelry, for scanning jewelry, and what would the resolution be?
Yeah, so that's a good question. This scanner is probably not the one that you would use for jewelry, because since jewelry is so tiny and has lots of little tiny details. The smallest resolution you could get with this particular scanner would be 0.25 millimeters. Now, that's not to say that Creaform doesn't have much sharper resolution, but this is the sharpest resolution you can get with the Peel 3 specifically.
Do you have any particular tips or tricks from your experience that you can share with people?
Oh, yes. Okay, here's one. If you're scanning a person, which I feel like maybe a lot of people here might want to do when they first get their hands on a 3D scanner, I recommend, because I gave a training yesterday, so it's fresh in my mind, I recommend scanning the face first, and then maybe getting under the chin and so on, and then going around and doing the rest of the head. Because sometimes, depending on whether, if you're not using any trackers or anything like that, there's a chance that you might be scanning, and this happens with pretty much every scanner, that you might be scanning a face, and then if you go around the head, which has a lot of hair and can be repetitive, there's a chance that when you come back over, the face might not match. So the nose might be like on top of the other part of the nose or something like that. So you always want to start with the face, get as much of that as possible, and then move around and get the rest of the head and the hair. So that would probably be one little tip there. That's a very specific one though, so I don't know if that's
very deep, very specific. And also before they get too bored and their face starts frowning, maybe.
Yeah, hopefully not. But yeah, it's kind of a quick one, so they can keep the smile. It's not too bad.
What does the sort of typical workflow sort of look like in use case scenarios, and sort of what is this sort of replacing really, and how much time might you save? I know it's a bit of a broad question. There's so many possibilities here, but perhaps you could talk a little bit about that.
About the workflow, about what that would be like?
Yeah, what would the workflow be like, and how does that sort of...
So essentially, you kind of just follow the steps that I showed here. You start with the parameters, you choose what kind of part you're going to be scanning. Then as you saw, you scan the part. I mean, you might have to put some stickers depending on whether there's flat regions or not, whether they're repetitive regions. And then once you're done scanning, you would do the cleanup. If you need to merge, you would add a new scan the other side of the part, flip it over, merge the two together. And the merging would be very similar to when I did it in the Peel.CAD software, where you first have to align it, maybe by clicking on a few points, and then you just say, okay, good to go, and it merges the two together. After that, you can bring it into your Peel.CAD software, your cleanup software, and you would typically do your clean mesh first, because that one kind of gets rid of a lot of the little things that might be in the way, like maybe triangles that are stuck, in the wrong direction or something. And it just does the cleanup for you there. If you can check the boxes of what is important to you. Then you would do any of the typical cleanups that we talked about, like hole fill, smoothing, maybe making some of the edges smoother. But it really depends on what it is that you are doing specifically. So if you're going to be 3D printing, or if you're going to be creating, the counter part of this, if maybe you just want to make a cover, maybe you want to make a shell of this, so you can give it a thickness, you can give it an offset. So many different things you can do. So many different types of workflows, but that's typically what you do. Once you do all the cleanup stuff, if you're going to be making a CAD, then that's when you create all the different features, and then you bring it into your CAD software from there.
We still have time for a couple more questions. So if you do have anything that you've thought of, please do send it across. I'm interested to know, have you encountered any challenges aligning, say, multiple scans for larger objects, and how do you address that? How do you sort of deal with scanning, things from
if I ever have an issue with scanning larger objects, then if it's something to do with accuracy, if I'm really going for the accuracy, there's a setting on here that allows you to basically force the scanner to see targets, and it has to track using the targets. And that's kind of like a dummy-proof way of making sure that everything's going to go as accurately as possible. And you would have to put targets all over the entire part, but then you are sure that everything's going to match up nicely when you come back around. And you also want to make sure that you're scanning with the shortest path, if that makes sense. I don't know if maybe I have like a little slide that I can show on it on the different thing. But when you're scanning, you want to make sure you're taking the shortest path between one point to another. So for example, if I'm going to be scanning a car door, I don't want to start on the bottom edge of the car door and then go all the way around to the other side and then kind of finish. Here, this is perfect. Here we go.
Oh, yes.
So I don't want to start here and then go all the way around to come back to the same point. What I'd want to do is I want to make the shortest path possible. So I kind of almost do like a flower pattern between everything. So kind of like something like this, where I would go start in the center because it's going to be the closest to every point. And then you go out and then come back in, out and then come back in. Kind of like when you bring it back to the center, it's almost like it's starting again. And that way you're not taking a super long path because it recognizes that first point again.
So useful to know. And how do you manage file sizes or formats for models when you're working with very large or intricate designs?
Yeah, good point. So if I'm going to be scanning a vehicle, for example, I might on maybe after I've scanned it, I would definitely want to save it as an entire session where I have all of my background data points. That's not just the mesh that we see here, not just the triangles that we see here, but it would essentially be all the millions of invisible points that are creating this mesh, that are helping us create this mesh. And there's much more that we can't see that are doing that. So I would save the session, and then on top of that, I would also save the mesh or the Peel.CAD file so that I can go back and clean it up as much as possible. But I also do want to make sure that, if I'm doing another project, I either save that session somewhere else so that I don't have to have it on my computer, or once I know the project's done and the customer's happy and I don't have to do any more cleanup on that specific project, I'll delete the session file because it's a much larger file, and I'll keep the STL. That way I can still refer to it later as needed.
Yeah. Right. Well, we don't have any more questions, but do you have any final thoughts for the audience?
I don't think so, but yeah, just if you guys want to follow us on Instagram, we'd always love to, post where we're going to be next, events like this, or if we're going to be at SEMA in Las Vegas. But we're all over the world, and we'd love to say hello and hear about your projects. If you want to ever tag us too in your projects, if you ever, come along and have a Peel 3 and you love all the projects that you're doing, you want to show off your stuff, feel free to tag us and maybe we'll repost you on a special story or something as well.
Well, Gabrielle, thanks for sharing your insights today. It's been very interesting for me and hopefully for everybody else. We will be sharing the replay, and if we didn't answer your questions, we will make sure we put you in touch with Peel to help you get the best out of your experience. So, Gabrielle, thank you again for joining us, and thank you everybody else.
Thank you so much. Have a great day.
Goodbye for now.